Morning Year 8. This is a bit of a weird topic to be able to find a video for you online, so I thought the easiest way would probably be just to make one. This is all about real life graphs, and then we're going to get onto motion graphs a bit later on in the lesson. But the first part is about discovering about flow rates and things like that on graphs, and this is a nice introduction to it. So here's somebody's story of their bath time. Now try and pause the video here and see if you can match each of these little explanations of what's going on to a part of the graph. Okay, so pause the video now, have a go at that, and then unpause and I'll show you the answers. Okay, so part A is going to be that the hot and cold taps are turned on. The reason it's that one is because you can see that the depth of the water, which is on this axis, is going up quite steeply in not much time. So in not much time, the depth of the water is rising fast. Okay, so both taps are turned on. Part B, it slows down a little bit, so the water is still getting deeper, but it's in the same amount of time, it's only got a little bit deeper. Okay, so perhaps one of the taps has been turned off. So with the hot tap, we discovered that it was slightly too hot, so putting some cold in. What's happening at part C? So at a horizontal section of this graph, that means the depth is not getting any deeper, but some time is passing. So what do you think would be happening here? Well, what's clearly happened here is that the cold tap got turned off, so there's no taps on, and the person is getting undressed. Suddenly, the water almost instantaneously gets deeper, and that is because our person has just got into the bath. Okay, so if you think about it, you get into the bath, the water immediately rises because you take up some of the space. Part E, nothing happening with the depth of the water because the person is just relaxing in the bath. F, suddenly the water drops almost instantaneously, so it's almost a vertical line there, but it does take some time, obviously some slight tiny bit of time, but the water level plummets, and that's the person getting out of the bath. Okay, so that space they were taking up is no longer there, and then the water goes down, and then part G obviously pulls the plug, and that's the water leaving at a constant rate, so a nice straight line. Okay, so I hope that made sense. It links with what we're going to move on to. So we're going to look at page 21. I'm going to skip the other pages because they're really for lessons. This is about water flowing from a tap at a constant rate into some different shaped containers, and we need to draw a graph to show what would happen to the depth of water as time increases. So in this first container, it's just a standard cylindrical glass, so your normal sort of glass that doesn't get thinner or wider at any point. Well, what would happen here is that it would just increase at a constant rate. The depth would just increase at a constant rate because nothing happens to the width of the glass. If you have a wider glass or a thinner glass at home, try turning the tap on and just leaving it flowing at a constant rate, and try changing the glass that you're putting underneath the tap, and notice see what you notice about how quick it takes to fill the glass up. What you should notice is that if you have a thinner glass, it fills faster, so at a steeper rate. Okay, and that's because it doesn't take as long to fill up this area at the bottom of the glass, whereas this is a bigger area. Okay, on graph C, we've got a different shaped glass which gets suddenly wider at the top. Okay, so it will kind of do what the one above did and rise at a steep rate because it's quite thin until it gets to this depth, but then at this point it will do what the glass in part A did and rise at a much slower rate. Okay, so there's that distinct change in the graph there. D is doing the reverse, so it's going to rise at a slow rate, and then when it reaches this depth, the glass gets thinner and it suddenly goes up much faster. graph E, I mean, who has a glass like this? This is just ridiculous. So it's going to go quite slowly to begin with because the glass is quite wide. Then the glass gets thinner, so it's going to go faster, steeper. The glass gets wide again, so the same width as before, so it should be the same steepness roughly as the first section, and then it gets thinner again. So we've got these 4 different sections, but these 2 lines are parallel, and these 2 lines should be roughly parallel. Onto these different shaped graphs up here. Now these are not going to give straight lines. Because the width of the glass is constantly changing, then so will the steepness of our line. It will be constantly changing, not just changing at a certain point in time, but all the time. So what's going to happen here is that it's thin at the bottom, so it's the depth of the water is going to start rising quite fast, and then as time goes on, the depth is going to continue rising, but slower. So it's going to go something like that. Okay, actually, let me just try that again. It's going to curve downwards. Okay, well, it will still be getting steeper, but sorry, it will still be rising, but getting less and less steep. This one is going to do the same, but in a less exaggerated way. It's not going to be as steep to begin with, so maybe something like that. And this one is wide at the bottom, but getting thinner as we go up. So it's actually going to do the reverse. It's going to fill up all the time. So it's always going to be increasing this line, but it is going to do it slowly to begin with, so almost horizontal, and then it's going to get steeper and steeper and steeper as we go. So a bit like that. And then on the final few, this one's just an example, I think. You have to draw the glass which might cause this graph. It's a nice question, this nice problem. This is showing the depth of water in a container that was full with a hole in the bottommost. So this time you can see the depth of the water is going down, it's draining. So on this first one, it drains quite slowly because there's a big area there. When we get to the thin section, just like when we're filling it, it will drain fast because there's not much area at each part. Okay, and then when it gets wider again, it will drain slowly. So this one is draining slowly to begin with, which indicates that the graph is the glass is quite wide at the top. Okay, so I'm going to go with that. And then it drains much faster here. Instantaneous change, so that means the graph got instantly thinner. Sorry, the glass got thinner. Okay, so it's kind of a T shape, this one. Okay, and then the bottom one drains very fast, so it must be very thin at the top. Then it drains very slow, so it must be quite wide. Come on, pen. And then it drains faster again, but not as fast as the first bit. So it is wide, it's thinner than the bit we've just done, but not as thin as the top. Okay, so again, never seen a glass like this, but there we go. Hope that made sense, and it's going to lead on to the